Okay, now we will go through question number 4 of your vectors 5. Okay, this question, if you read through, the first part of the question asks you to find an equation in the form of r equals to a plus tb, which is your vector equation form for the line passing through P and Q. And then, they give you another equation of the line, and your next job is to show that the lines L and PQ intersect, and subsequently find the coordinates of the point of intersection. So a few things must run through in your brain when you read a question like that. Analyze and understand. First job is to find equation of the line PQ. Thereafter, you need to show two lines would intersect and subsequently find the points of intersection. So this is the train of thought required to handle a question like this. So we start off with finding the equation of the line PQ. So to write down the equation of the line PQ in vector equation form, I will need one point and one direction. So this, if you're not sure how to proceed, just refer to example 1a and 1b in your lecture notes. So first part, as I said, to find out the vector equation of the line PQ, I need one point and one direction. And the direction we are talking about will be direction PQ. So from your vectors chapter 1, you can find vector PQ by using OQ minus OP. And that will give you 3, 6 minus 9. So this will be your direction that you're interested in, which is your B. So whether you use 3 minus 6 minus 9 or you just use 1, 2 minus 3, it is perfectly fine because I'm interested only in the direction. So I have one direction, I need one point. So who is the point to use? I can use either point P or point Q to fit in and find the equation of the line PQ. And so this is your A plus TB. So that's the first part of the question done. The next part of the question asks you to show that the line L follows this equation and the line PQ intersect. So your job now is to find the intersection of two lines. But before you find it, you need to show first. So very similar to example 1b in your lecture notes, I need to equate the two equations together. This is the equation of the line PQ. This is the vector equation of the line Q. I need to equate the two equations together. Remember, start off with consider equation of a line PQ equals to the equation of the line L. So what you need to do next is to look across horizontally. You're going to generate three different simultaneous equations. Three simultaneous equations with two unknowns. Your job is to show. So I can only use any two equations to solve and verify with the third equation. I repeat, use any two equations to solve and verify with the third equation. So for tutorial purpose, we are using equation 1 and 2 to solve. So solving equation 1 and 2, I get S is equals to 2 and T is equals to 1. I need to substitute these two values into equation 3. Check the left hand side and check the right hand side. They are consistent, and therefore you can conclude because T equals to 1 and S equals to 2 satisfy equation 1, 2 and 3 concurrently. Line L and PQ intersect. And substituting either value of S or either value of T back into your original equation, I can find your so-called point of intersection of the two lines. That is all for chapter question number 4 of your tutorial.